One of the things that MaxScript does particularly well is work with collections of things. So far, we've seen only the beginnings of this in the form of for loops over scene object collections such as geometry and cameras. In addition to this, you can build and manipulate your own complex collections in various ways, specify custom scene object sets with name patterns, and take advantage of so-called collection mapping, in which many of the built-in and even user-defined functions can operate automatically on all the elements in a collection without you needing to write a loop. The main way you create your own collections is by using the array value class. This lets you build an ordered list of values that you can add things to, delete things from, access individual elements in, and loop over, and so on. You can build an array just by writing a list of values down in an array literal like this. The hash sign, followed by an open parenthesis, begins a comma-separated list of expressions, ending with a matching close parenthesis. You can make this list as long as you like, and put any mixture of value classes you need in it, including other arrays. Once you have an array, you can work with it in several ways. You can loop over it with a collection for loop, like this. In this case, the source for the for loop is the array in the variable a, and the loop binds the loop variable I to successive elements in the array each time around the loop. The body in this case prints the square root of the loop variable, so we get the square roots of the original numbers in A. Individual elements in an array can be accessed with the indexing operator like this. You supply the index of the element you want inside square brackets, which is placed just after the array value. The index can be any expression, of course, so long as it evaluates to a number. The first element in all MaxScript arrays is at index 1, unlike some languages such as C++, in which the indexes start at 0. If you try to use an index that is outside the array, you get back the special undefined value, same as you would do from uninitialized variables. You can also change an array element simply by assigning to it like this. And if we look at the array again, you'll notice that the third element has been changed. Arrays can be pretty much any size, and you can add to them and build them in a number of ways. One way is to use the append method like this, which tacks new elements onto the end of the array. It's also very common to use append in a loop to build an array element by element. We could have made the array of odd numbers like this. You start out with an empty array you can add things to, and the for loop runs I from 1 to 10, and the if expression here selects the odd numbers using the mod function to test if the loop variable is divisible by 2, and then appends the loop variable to the forming array. Let's run it. And look at the array, and here indeed are the odd numbers. The advantage of the loop is, as always, that you can make the loop count anything you want, and so make an array of any size. You can also extend arrays by assigning directly to elements that don't yet exist in the array. MaxScript will automatically extend the array as needed. So, if I say something like this, assigning 42 to the 10th element in the array, and then look at the array again, you see it now has 10 elements, with 42 in the last. The yet-to-be-assigned elements are undefined, as would be expected. Perhaps the coolest way to build arrays is with the expression form of the for loop. Here's an example. If you use the word collect here instead of do, the for loop runs as usual, but collects the value of the body expression at the end of each iteration into a newly formed array. Here I've collected an array of square roots. The for loops the loop variable I through the values 1 to 5, and collects the square root of each of these values into an array and returns it as its value, which we've assigned to the variable roots here. The loop body can of course be a block expression, in which case the value of the block, that is the last expression in the block, is collected each time around. There is also a selective or filtering form of this loop, which is handy for collecting only certain of the loop values. Here's another version of the odd value array loop, this time making use of this selective form of the for loop. So let's run it again. And indeed we have the odd numbers. The difference here is the where clause added after the source. This says only perform the collect part of the loop this time around if the Boolean expression after the where is true. So again, the mod test will select only odd numbers. This kind of for expression is very useful for grabbing complex sets of objects from the scene. For example, if I wanted to collect all the low poly spheres into an array, I could say something like this. I'm looping over all the geometry in the scene and using a where clause to select the objects whose class is sphere and whose number of faces is less than 50. These arrays of scene objects are much like the named selection sets in the main Max UI. Before looking at more of the capabilities of arrays, I want to show you a larger script that uses arrays to good effect. This is an enhancement to the sphere creator dialog we created early in the presentation. Here it is again to remind you. It defines a dialog with some parameter spinners and a button to create a line of touching spheres. Recall that if you want to change the count or growth parameters for the set you've just created, you have to delete them and change the parameters and then create them again. It would be much cooler if you could adjust the spinner values after the set was created and have it update the existing spheres on the fly. And here are the modifications needed to do this. The main idea is to grab the created spheres into an array and then apply the changes to them in new change handlers for the growth and count spinners. So let's run this to see how it works. Okay, here's the dialog. I press the Create button, and the spheres are created as before. But now, if I adjust the growth spinner, you see the spheres adjust on the fly, still maintaining touch. And if I change the count spinner, I get more or fewer spheres. You can also hit the Delete button, and all the spheres go away. This is almost a standalone object system, something like ring array. Okay, let's look at the code. I've added a local variable named spheres up here, which will hold the array of new spheres, and I've initialized it to the empty array. By declaring a local variable here at the main block level in the definition, it's in the rollout's main namespace, and so is shared by all the handlers. But it's hidden inside the definition and won't interfere with other code outside. Further, it will be created and initialized when the dialog is first opened, and retired when the dialog closes. Next, I've modified the Create button handler ever so slightly, turning the original for-do loop into a for-collect loop, so that it collects the created spheres into an array and stores them in the spheres rollout local variable. I've also added a pressed handler for the new Delete Spheres button next, and you can see it's calling the delete function on the array. Delete is one of the node built-in functions, like move, rotate, copy, and so on, and it simply deletes a node from the scene. The delete function notices that you've given it an array rather than a scene object, and automatically applies itself to all the objects in the array, and deleting them all from the scene. This is called automatic collection mapping, and many of the built-in functions are set up to do this. It saves you having to write a loop over the array, manually calling the function on each element. You can tell if a function supports automatic collection mapping by looking at its definition in the help file. See here in the Node Common Properties and Methods page, all the collection mapped functions are marked with the word mapped. Following this are the change handlers for the spinners. Whenever the user adjusts the growth spinner, this handler will be called with the new value of the spinner as a parameter. The handler runs a loop adjusting the radius and position of the spheres in the holder array to match the new growth value and so still keep them touching. Since I want to base the new radius and position on the sphere's position in the line, I've used a range for loop here to give me numbers from 1 up to the current number of spheres. Arrays have a .count property that tells you how big the array currently is. So if there were 12 arrays collected in the array, sphere.count would be 12, and the loop would make I go from 1 to 12. Inside the loop body, I use the array indexing syntax to update the radius and position of successive spheres in the array, using the original expressions for growth and position, but based on the spinner value parameter passed into the handler and the loop index. The last handler is for the changed event on the count spinner. In a somewhat heavy-handed way, I simply delete all of the current spheres and create a brand new set by simulating a button press on the Create button. The event handlers defined for a control are accessible to other code as properties on the control, with property names the same name as the associated event, and you can call them just like you call other functions. So this call invokes this handler, which runs the creation loop again, creating a new array of spheres, which replaces the out-of-date array in the sphere's local variable. Before we leave arrays, I want to quickly mention some of the methods available for manipulating them. They're all documented in the methods section for array values in the MaxScript help. As you can see, you can copy arrays, insert and delete elements, sort them, find elements in them, and join smaller arrays into larger ones. Here's a final array example using the append method to collect objects in a scene hierarchy. The addChildren function builds an array containing all the descendants of a given scene object in a scene hierarchy, kind of the equivalent of double-clicking on a parent object in the scene. It's another example of a recursive function working on a nested hierarchy. So here's a scene with a hierarchy of boxes and a hierarchy of spheres. And if I call the function on the top level box, I get back an array of all of the nodes in its hierarchy. The function takes two parameters, a scene object and an array to add the object's descendants to. Notice in the sample call I gave it an empty array as the second parameter, so we wind up with just box01's descendants. Writing the function in this way lets me use it several times to accumulate a number of hierarchies. For example, I could now say something like this, calling the function on a different parent object, but giving it the array I got from the first call as the second parameter. And now it's adding sphere01's descendants to box01's, updating variable c with this new joint array. Let's walk through the body of the function to see how it works. First, it adds the main parameter object to the accumulating array, and then loops over the children of that object, recursively calling itself on each child. This in turn causes each child to be added into the accumulating array, and then to be scanned itself for children, and so on until there are no further children in the hierarchy. After all the branches of the hierarchy have been descended down, the original call returns the parameter array, updated with all the descendants appended to it. Okay, once we have the array of objects, we can do interesting things with it, like looping over it or applying automatically mapped functions. Let's apply the select function, which selects objects in the scene. It's a mapped function, so, as you can see, it selects all of the objects we've collected in the array in C. Property assignment is also mapped over arrays, so I can say things like this, which sets the .var color property of all the objects in the array in C to blue, as you can see.